ഹലോ സ്റ്റുഡൻസ്, നമ്മുടെ മെറ്റ് അനാലിസിസ് പ്രാക്ടിക്കലിന്റെ ഭാഗമായിട്ട് നമുക്ക് ആകെ ഒരു പ്രോബ്ലമേ ഇപ്പം ചെയ്യാൻ സാധിക്കുകയുള്ളൂ. ചാർട്ട് അനാലിസിസ് നമുക്ക് ഡീറ്റെയിൽ ആയിട്ട് അത് മാപ്പിൽ വരച്ച് ചെയ്യേണ്ടതാണ്. അപ്പൊ ഇപ്പം ഒരു പ്രോബ്ലത്തിൽ നമുക്കിത് വൈൻഡപ്പ് ചെയ്യാം. അത് സ്റ്റേഷൻ മോഡൽസ് വരയ്ക്കാം. സ്റ്റേഷൻ മോഡൽസ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നമുക്കറിയാം ഈ ഒബ്സർവേഷൻസ് വരുന്ന സിനോപ്റ്റിക് ഒബ്സർവേഷൻസ്, അതായത് നമ്മുടെ IMD-യുടെ ഒക്കെ മെറ്റീരിയോളജിക്കൽ ഒബ്സർവേറ്ററി എന്നുള്ള ഡേറ്റ അതേപോലെയല്ല ട്രാൻസ്മിറ്റ് ചെയ്യുന്നത്. ദേ ആർ ട്രാൻസ്മിറ്റഡ് ഇൻ കോഡഡ് ഫോം. അതിനൊരു കോഡ്, പ്രത്യേക തരത്തിലുള്ള കോഡ്സ് ഉണ്ട്. സോ ദിസ് ഹാസ് ടു ബി ട്രാൻസ്ഫേർഡ് ടു other regional met centers and to worldwide. We have to disseminate this data. So it is in a coded form. The first thing is that we have to decode this data first, and then we have to draw station models with representing these data sets on the map, and on that we are doing some chart analysis like isobaric, times analysis, and isotac analysis, like that. So the crux of this problem is we have to represent the data in the station model. So for a typical, we will draw only a typical inland plane station. So each station we have to represent like this. So this should be the center of the station, represented by N, and here we have to represent the wind speed. If the wind speed is 20 knots, we have to represent like this, in which this pointing is the direction DD, and this is the FF. That means the wind speed in knots. Then there will be symbols like low cloud type, middle cloud type, and high cloud type. And there is another symbols NH by H. Here this N is the total cloud cover in octas. So this we have to represent in a symbol forms, not in the numeric forms. This NH is the cloud cover of lowest level clouds in octas, and this H is the height of the base of low level cloud. Then we have to represent WW. This is another important parameter for a manned observatory. This is the present weather condition. So this also will be represented with some symbols that we will discuss later. And there is another parameter VV. This is visibility, and there is TT. This is dry bulb temperature. There is TD. This is viewpoint temperature. So then here we have to represent the mean sea level pressure in thousands of decimal points, and then P24, P24. Precisely, this is pressure. This is MSLP, mean sea level pressure, and this is the pressure tendency. That means during last 24 hours. So if it is increasing, pressure is increasing with respect to yesterday, we have to denote like positive. Pressure is decreasing, negative. So these are the main things, main parameters we are representing in a station model. Based on this, we have on a map we have represented on every station points. Then based on these parameters, we are doing the synoptic analysis. So these are the minimum required parameters. These are not. This will not cover. If you look at the uh, coding books, there will be more than 300, 400 pages of codes. So each one. So that is we don't have to go through all those coded messages. But this is the minimum requirement to represent the data in the station model format. ശരിക്കും പറഞ്ഞാൽ ഇതൊരു അസ്സലാമു അലൈക്കും ഉള്ള സംഭവമാണ്. നമ്മുടെ ഈ അനാലിസിസിന് വേണ്ടി മാത്രം ഞാനൊരു കസ്റ്റമൈസ് ചെയ്ത് പറയുന്നതാണ്. ബട്ട് കോഡിംഗ് ഈസ് മോർ ദാൻ ദിസ്. ബട്ട് ദിസ് ഈസ് ദ മിനിമം തിങ് വി നീഡ് ടു നോ വൈൽ decoding the coded message and making a station model. So first, how we will find out this? Because I am giving data in a very simple form because it is mostly coded form will be in the running head, but I will give the data in a more understandable form. You don't have to go to the coding book to decode this message. Based on whatever minimum parameters required for plotting a station plot, that much only I will give in a as a coded message. So that you have to decode and then plot a station model. So I will give data in this specific format like mi, mi, mj, mj. This is the mj, and then uh, yy, gg, iw. So this represent the form of the data types. So if it is a synoptic data, this will be AAXS. If the data start with this letter, we can assume that this is a synoptic observation from a inland station. So that is the meaning of that. So this is the first section, and then along with that there is another five digits that II, II. So this is nothing but WMO station number, and this is the date format, and along with the IW, whether it is manned or the wind speed is represented, means measured using anemometer, and whether it is in knots or meter per second, like that. This is a just like an indicator. So here YY is the day of the month because we are doing observation every day. So irrespective of we don't have to give the month, so we have to give at least the day of the month. Then GG is the UTC type, that is synoptic type. IW is an indicator for wind. So these are the first section of uh, the coded message. This is the first section. So section 0. This doesn't contain any data. This will contain only some basic information regarding the type of the data, time and hour of the operation. Then some from which WMO station this observation is coming. Then IR, IX, HBV, and after that, here these are also kind of indices. This is index for rainfall. This is again index for charge. Okay, and this H is the H I have defined later, the height of the base of the lowest cloud, and this is the visibility. IR and IX are indices for whether rainfall is included and whether it is a manned observatory and whether the present weather information is included. Because present weather information normally included in a manned observatory because somebody has to take the visual observation. So unmanned automatic observatory it is very difficult to give WW, that's the present weather situation. And then comes NDDFF. So this is our the octaves, number of octaves of cloud. And DD is the wind direction. So wind direction is normally plotted from the 0 is the north. Like that, you have to plot the wind. It varies from regarding wind direction like this. It varies from 0, then 9, 18 up to 35. If DD is 09, that means wind exactly blowing from east, like this. If wind speed is 13, somewhere in between 9 and 18, wind is blowing like wind direction is towards the station. So from which direction wind is blowing towards the station, so that is the wind direction. So this varies from BD varies from 0 to 35. 0 is the north, 35 is the northwest. So here 9 is the pure east, 18 is the pure south, and 27 is the pure west. So this is regarding the wind direction. And FF is the wind speed in knots. This, whether it is in knots and all, you will get from this indicator. FF means wind speed in knots. If FF is 55, it is 55. If it is more than 105 knots, we have only two. We have to take only these two digits and add another 60 to wind direction. So that if it is there, wind direction is greater than any digit greater than 35 degree, then we have to consider that its FF contains very high wind speed. So that is why during cyclonic time and all we represent FF like that. Then comes one SNTTT. So one is just an indicator. It is uh, uh, which is for representing the temperature. And SN is the sign of the temperature. 0 means positive. I think it is 0 means positive and 1 means negative. TTT the 100 decimal accuracy. accurate temperature observation. That means if it is 27.6, then this will be 27. That means if it is 10276 means this positive temperature is 27.6. This is an index, just an index telling that this is for temperature. Then 2 SN TD TD. Similarly, this SN represent whether it is positive or 0 means positive. TD if it is 26.5 to 20265. Then we have now we have almost all parameters. Along with we have another parameter for P P P P. This is the mean sea level pressure in thousands of decimal points. Suppose the MSLP is 987.5. This will be 49875. If it is 1000, 4.8, then it will be, you have to omit first 0, 4. So like that you have to represent. The next important parameter is the 7 WW W1 W1. So this WW is the present weather situation. So this we have to take from the W1 W2 is the past weather. This normally we don't use for station model, but still it is similar to present weather what are present in the past before taking the observation. Then one more important record is the 8 NH CL CM CH. So this already I discussed. NH is the height of the lowest number of hectares of the lowest cloud. CL is the type of the low level cloud. CM is the type of the middle level cloud, and H is the type of the high level cloud. So this also we have to represent in symbol form. So these are the Assalamu alaikum or minimum required parameters to plot a station model. So now we can decode, try to decode a data. So keep in mind we will use for so now based on this, this should be, this we have to keep in mind. So our station model is like this: N L CM CH NH by H, then wind DD F of, then P24, then WW present weather, then VV visibility, driver thermal. These are the minimum required parameters for a station model. So for this, or if our data, normally our data starts like this: there is no space, and XS 08004, then 42492. Continuously there is no space. Then 21495 80910 10 276 20 6 5 40 004 76062 8421 580. So this is the ordered data. So here you recall what I have written earlier. So this is in the form of A, XS, G, YY, GG, IW, II, III, then IR, IX, H, BV. These are the records. Then N, D, D, FF, then 1 SN, T, 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 2 SN, TD, 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 4 P, 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 7 W, W, W1, W2, 8, 8 NH, CL, CM, CH, then 58 P24, P24, P24. 58 is just index. 7 is just a starting index. 1 is starting index 2. This section 0 doesn't contain any data. This is section 1. Section 1 only contains data sets. This comes in another section 5.5, starting with 5.5. I am not discussing that. Before that also there is another section starts with 333 for rainfall and all. But these are the minimum. So based on this sequence, you have to decode this data to make this station move. So how to do that? Here I need n. First I need n. So what is that? N is the number of octas, total cloud cover. So here this we have to represent with symbols. So here n is what this for yeah, yes, n is something like 8 octas. That means n is 8 octas means 8. If 8 full cloud cover means 8 octas. Half cloud cover means 4 octas. Quarter cloud cover means 2 octas. Like that, you have to divide the entire sphere into 8 means full octas. You have to draw a circle and shade with a dark shade. So then that comes full octas. 8 octas is represented by, I will show you in another because I have already sent that symbol to you. So here the symbol corresponding to this is like this. Here this is the symbol. This is the symbol. So n8 means you have to represent like this. Represent n this full shade. Then we should know what is the DD and FF. DD is 09. 09 means exactly wind is blowing from east. So wind is blowing from east. Line. Then FF is 10. 10 knots means you have to draw one single line. If it is 20 nodes, man, one full line means 10 nodes. 25 nodes you have to represent like this. Half means 25. 50 nodes you can, instead of this 5 slash will form a display. 55 means like this. So here it is only 10 nodes. You have to draw a full line. Exactly drawing from east. Then we have to take H and VV and also NH. Here the things start with 8. The second digit is NH. That means 4 and H is here. H is section 1 which start with IR, IX. This is the H. 4 by. Then we should know CL, CM and CH. Where comes start with 8. 8 NH. NH already we have decoded. Then CL 6. CL is 6. Again you have to go there and take this symbol. Here CL6 means CL. Take CL column, then 6 corresponding to 6. This is the symbol for CL6. And CM here it is 2. Then take CM column, go to 2. This is the symbol for CM. CH is 1. Take CH column, then go like this. That is the symbols. So here CL is 6. This one NH is 4 by 4. CL is 6. 6 we have to represented like this. It's a type of cloud. And then CM. CM is 2. That is CM is 2. That is something like this symbol. And CH is 1. Normally symbol status cloud. So then we should know PPP and P24. PPP start with 4. Here this is the PPP component. As I said, if it is this is thousands of decimal degrees and the points, then 0004 means 1004. This is how to draw 0 and P24 means here from 58 we have 0. 58 is the index. After that 012 is P24. We don't know whether it is increasing or decreasing. So don't have to include positive or negative. Then coming back to here WW you will get from 7, starting from 7 WW W1 W2. So here 7 WW is 60. So here symbols corresponding to WW 60 is something like here. From here we can take WW60 corresponding to somewhere here. This one. So here a dot point that you have to represent here. A dot. Then VV VV is this. VV, this one 95. VV is very high visibility. 95. TT, you can omit decimal point here. This one SN. This is TD. 27.6. Here you have to write 27 degrees. And TD is 26.5. Here 26. This is how this data, after making the station plot, this data looks like this. All regarding the station models. So I will give 2-3 examples to practice with that, and then in the exam I will ask only 2 or 3 this type of. I will give 2-3 this coded data. You have to decode, then what this station model. This is for the exam. Thank you.